All right, thank you for the introduction. Good day, everyone. So let's just dive right into the topic. And first, I want to explain to you the SAFE4SOC architecture. So consider this typical scenario. You have different security operations centers, each operating in a different domain. Maybe SOC 1 is dealing with health alerts or something like that, or Security Operations Center 2 deals with military stuff, or Security Operations Center 3 covers some industrial plant or something like that. And all of these SOCs have different proprietary formats for their alerts. And our aim is to establish the following. We want to create something like a Security Operations Center for all other Security Operations Centers that want to participate. And as you can see here on the graph on the right-hand side, there is a module which is called ISGW, that stands for Information Sharing Gateway. And the idea is that each of these SOCs can deploy one of these gateways. And in the end, the gateway is taking care of the transmission of the alerts to the central Security Operations Center, which is red at the top. And the idea is to have a workflow where all the alerts are using the same format. So all the alert mappings need to fit into this format. And this is basically the main core idea, creating a SOC of SOCs. And why do we do that? Of course, the Central Security Operations Center acts as a situational awareness platform. The central SOC can see things which the individual SOCs 1, 2, and 3, for instance, cannot see. So the idea is to collect the alerts and aggregate the information to create cyber threat intelligence. So in the end, the situational awareness platform, the Central Security Operations Center, has the aim to derive information from all the other collected alerts. And this cyber threat intelligence, in short CTI, is afterwards made available to the participants, or even for some people via public endpoint. So the idea is to create cyber threat intelligence from all participants. So to give a more hands-on example alert flow, so on the left-hand side, you see the local Security Operations Center. And for instance, you might have some source of the alert. In this case, maybe it's QRadar, which is a well-known technology in the field. And the alerts from QRadar are formatted in the corresponding QR format. And the first component that we needed to develop to establish this workflow is the SIEM Gateway, which you can see on the left in the middle. This gateway has the purpose to transform the proprietary format of the alert into the standardized IDMEF version 2, which Gilles just introduced. And afterwards, after the formatting, the transformation is done. This new alert format is forwarded to the information sharing gateway on the sender, on the side. And afterwards, of course, via typical state-of-the-art technologies, HTTPS, and using the internet infrastructure, this format is securely transported to the Central Security Operations Center on the right-hand side. And here we have the information sharing gateway acting as a receiver, and it forwards this standardized alert to the Concerto receiver and afterwards to a Concerto SIEM. And here all the magic happens, all the CTI generation is going on. And my colleagues will show more about that in the next slides after me. But right now, I just want to focus on the two components here, the gateways. Before I go in more detail, I have to say some things about the background. Because as you all know, if you're working in the field, sharing alerts is really difficult. There are some cases where it's not that difficult. For instance, if you just want to share some insensitive alert, like something like you have a botnet attacking you and you just want to share the IP address of the attacker. There's no harm in doing that. It's not that difficult. There's no sensitive information that can harm you. But of course, there exist a lot of sensitive alerts that you can't just share because it would be dangerous for your company or for your organization. For instance, if you publish your alerts, it may harm your company's reputation, or it might encourage further attacks. And sometimes it's not even possible to publish your alerts due to legal restrictions. For instance, maybe you have to keep some contract terms or things like that. So in any of these cases, the data must never be leaked during transmission. And that's why security is so paramount. It is really important that the transmission is secured and all these issues have been taken care of. And just to give you an example, you can't just share damage information or the IP address of a victim computer or a list of your vulnerable components or something like that. But on the other hand, if you would be able to share these pieces of data in a secure way, then you could really benefit as a society or as a community, because then you can produce more advanced cyber threat intelligence. So to take care of these issues, we need to take care of the following things. First of all, before sharing any kind of alert, we need precisely defined processing rules. It needs to be known beforehand what can be done with the alerts that were collected, and beforehand it must be clear which fields of the alerts must be anonymized or pseudonymized, etc. So we need some filtering for the attributes, and also in some cases we need to predefine whether some enrichment or replacement has to be performed. For instance, maybe some data, maybe missing data needs to be added or something like that. And the solution that we came up in this SAFE4SOC project is the information sharing agreement. It's basically a technical contract which has to be agreed upon before the alert transmission. And this specifies exactly which IDMEF version 2 fields may be modified or have to be adapted, etc. And it's basically a human readable JSON format. So that's about the background, and now I'm going to explain to you the technical components, the two gateway kinds. So as mentioned before, now we talk about the Security Information and Event Management Gateway, in short, the SIEM Gateway. So this component has the purpose to receive the data in a native proprietary format. In our example, this was QRadar, and it transforms the data into IDMEF version 2 format, and it forwards the new IDMEF version 2 alert to the information sharing gateway. And the good thing is, of course, we work a lot with open source components. So our code is either already published or will be published at the end of the year when the project is done. And now we're just doing some quality assurance and things like that. But you can join if you want to. We can give you access beforehand for most of the components, I think. And the idea is to cover most of the dominant industry-leading formats for alerts, so that these SIEM gateways can transform the proprietary formats into IDMEF version 2. And of course, it's open source because we need to have adaptability, and people need to trust that these components do exactly what they should be doing, and there's no backdoor inside, etc. And this is the first part that we worked on, the SIEM gateways. They do the transformation. And the second part, the second component, is the information sharing gateway, in short ISGW. And this is the technical entity which deals with securing the alert transmission. So of course, the main functionalities include authentication of endpoints. It of course encrypts the traffic between sender and receiver, and it checks whether the configured information sharing agreement can be kept or whether it is applied or not. And of course, this component also has automated enforcement for filtering or enrichment, which can be pre-configured using the ISA. And of course, in the end, this gateway has the purpose to forward all the alerts in IDMEF version 2 format from entry point, which in our case is the local SOC, to the exit point, which is the central SOC. So, of course, this component is also open source. all participants can inspect the code, and we do that so we can enable transparency and we can allow people to adapt the code if they want to. And the main purpose is basically just to have a simplified setup so that anyone can easily join a SAFE4SOC enabled community. And you can simply run it with 2 or 3 commands in a command line using Docker Compose. And of course, the same component, this information sharing gateway, can either be configured as a sender or receiver. So you can start your own SAFE4SOC ecosystem, or you can join our demo stuff, etc. Okay, so just to sum up the information, here are some key points or some take-home messages. So the first thing that SAFE4SOC has enabled is alerts can now be transformed and transmitted automatically, all the way from the alert source over the SIEM gateway to the information sharing gateway to the central SOC. So the alerts are transformed and transmitted securely. The second thing that SAFE4SOC enables is basically just we provide an infrastructure that is ready to use for centralized cyber threat intelligence generation. The components are free to use, it's open source. And as mentioned before, the final versions of these components are published latest December 2026, but you can already get access if you want to. And the alert transmission is secured and it has been taken care of to deal with the security issues because we provide out of the box encrypted, integrity protected, and authenticated communication according to the state of the art. And in the end, the SAFE4SOC architecture allows processing of alerts which are conform with a pre-configured contract. This is our information sharing agreement. So these are the concepts and components that we developed in the SAFE4SOC project to implement the architecture, which I have shown you before. Yeah, this is about it. And now I'm open for some questions maybe, but